My name is Chris Foote, and I'd like to welcome everyone to today's Microsoft Business Intelligence presentation. We'll be uploading a copy of the presentation to SlideShare tomorrow morning. All participants will be sent a follow-up email that includes a link to allow you to download a copy. By default, GoToWebinar mutes all participants except the speaker. That's a good thing because it reduces the chance of background noise affecting the presentation. We're going to hold questions until the end. There's a button on the GoToWebinar panel that will allow you to type your questions in. Kelly, who's the webinar's organizer, will bundle them up and we'll discuss them at the end. We're going to be respectful of your time. We know that many of you will have meetings right after this one. We've timed the presentation and demo to allow Q&A at the end, but if we're in danger of running over, we can always respond to remaining questions by email. Our intent is to have these RDX Insights presentations monthly. Next month's presentation will focus on the increasing interest in open source relational database products. Their popularity continues to grow. They're being viewed as viable replacement for their commercial counterparts. We'll discuss the products available, which include the perennial favorites, as well as some of the relational newcomers. I also distribute a monthly newsletter that you might be interested in. It covers interesting technical topics that we think would benefit our customers both personally and professionally. This month's newsletter includes articles on evaluating and selecting cloud DBMS architectures, a link to a video presentation on storing video and images in NoSQL, SQL Server on Linux, and Amazon Aurora's new PostgreSQL compatibility. Each newsletter also has a helpful hint on how to maximize your relationship with RDX. If you'd like to be added to the distribution list, please let me know. You can also add me as your LinkedIn buddy. I write articles and SlideShare presentations on a lot of different wide-ranging technical topics. So let's get started with today's presentation. The products we'll be discussing today include the perennial favorites, SQL Server integration services, analysis services, and reporting services. But we'll also talk about a product that is gaining an increasing amount of attention from both Microsoft and the BI user community, Power BI. We'll provide a high-level overview of the SSIS, AS, and RS tech stack, but we're going to dig a little more deeply into the Power BI offering. RDX is a large team dedicated to the Microsoft Business Intelligence product suite. We have the good fortune of having one of the most senior managers on that team, Jeremy Frye, provide a Power BI demo at the end of this presentation. Jeremy's team works with all sizes of companies from small to Fortune 100 organizations and in all areas of Microsoft BI technologies. This team provides a full lifecycle of support services from initial system architecture design to building dashboards and reports. This market vertical is huge, and Microsoft has some stiff competition coming from Tableau, which I have used heavily, Cognos, Oracle, SAP, SAS, TIBCO, MicroStrategy, and Qlik, to name just a few. We know that the SQL Server database provides a strong foundation for a BI data store. Microsoft's SSIS, AS, and RS are built on that foundation. You have to buy the SQL Server database to get the SSIS, AS, and RS tech stack, but it's included with the product. Its chief database competitors don't bundle BI products into their core database software. In addition to product functionality, the bundling of those tools into the database is a strong driving factor for Microsoft's commercial success in the BI space. Power BI is also a very cost-effective offering, starting at $9.99 per user for the cloud service, and the Power BI desktop is free. I think the greatest benefit of Microsoft is that for a company of its size and broad range of product offerings, it's pretty nimble in the BI area. When we look at some of the capabilities provided by Power BI, Microsoft is demonstrating that the company understands the BI market. Not only is it keeping pace with its competitors, it is also surpassing them in many key areas of business intelligence technologies. That's a pretty strong statement to be able to make, considering Microsoft is competing against large, long-standing, entrenched competitors that focus on nothing but business intelligence. In order to slice, dice, and evaluate operational data, you need to capture, cleanse, and transform it, and then store it for analysis. SQL Server Integration Services is Microsoft's on-premises platform for building enterprise-level data integration and data transformation solutions. SSIS provides wizards that allow you to create and schedule workflows that feed business intelligence data stores from a wide variety of disparate data sources. The product also allows you to perform cleansing and transformations to make that data consistent. You can use the integration services tools to create these solutions without writing complex programs. You can also choose to embed transformation and cleansing code into the workflows if you need to perform more complex processing. Analysis Services is an analytical data engine used in decision support in business analytics, providing the analytical data for business reports and client apps such as Power BI, Excel, reporting services reports, and other data visualization tools. SSAS uses the data captured by SSIS and other ETL products, as well as traditional data input sources, and turns it into meaningful information that is purposely designed to facilitate better business decisions. That information can then be accessed by a myriad of data display tools. On-premises SSAS has a cloud counterpart called Azure Analytical Services, which provides like functionality. We know that tables are the typical schema object used to store data in a relational database. They're perfectly acceptable, although not always the most optimal sources for business intelligence applications. Cubes are multidimensional objects that are purposely built to facilitate online analytical processing. Both cubes and relational tables are storage objects for data used as input to BI analytics. Each one has their strengths and weaknesses and optimal use cases. When we begin discussing Power BI, we'll learn that it has a very tight integration with SSAS. There are multiple mechanisms to connect Power BI and SSAS together. For example, Power BI offers a live connection to SSAS that allows Power BI to access both analysis services, tabular and multi-dimensional cube models. In addition, you can publish traditional Power BI reports, which we'll discuss more deeply in upcoming slides, that are built using SSAS data as the source. SQL Server Reporting Services is an on-premises solution for creating, publishing, and scheduling reports and delivering them to your end users. You can design reports that adjust automatically to different form factors, such as tablets and mobile phones. The product really excels at simple and complex visualizations. It covers all aspects of reporting, from design and scheduling to delivery. You can connect the product to a Microsoft database, as well as disparate data sources like Oracle, SAP, and Teradata. You can create KPIs, secure the reports, set up subscriptions and alerts. It really is all-encompassing. This is the SSRS architecture. Microsoft is continuing to vigorously enhance SSRS. The web portal really improves its usability. Here's an example of a very beneficial enhancement to SSRS. The Reporting Services web portal is a web-based offering that allows you to view reports, including mobile, KPIs, and navigate through the elements that are in your report server instance. It provides mechanisms to view, search, print, and subscribe reports. You can configure role-based security that determines access to items and operations. You're also able to configure report execution properties, report history, and report parameters. You can also create KPIs. In addition to enhancing the product's standalone features, Microsoft is strengthening the integration between SSRS and Power BI. SQL Server 2016 Reporting Services enables users to pin Reporting Services report items from the Report Viewer toolbar to a Power BI dashboard as a new tile. We'll talk about tiles in Power BI in a few slides here. In a 2017 tech preview, Microsoft showed the latest feature, which allows you to upload and view Power BI reports from the SSRS web portal. Let's move on to Power BI. Compared to SSIS, AS, and RS, it's a new kid on the block, and it's attracting a lot of attention from the IT community. Power BI is a suite of business analytics tools to analyze data and share insights. Microsoft accurately describes Power BI as an end-to-end solution for building analytics. It really does cover the complete analytics lifecycle, from connecting to dozens of different data sources, performing data preparation, building robust visualizations, and facilitating both traditional and ad hoc analysis from desktops and mobile devices. I found this graphic, which was free to use from Dustin Ryan's site. I used it instead of creating my own, as I think it very accurately depicts the Power BI architecture. Here's what's important to know about this architecture. There's a Power BI desktop and a Power BI service. Both products provide data access and display features. The Power BI desktop can be described as a high-powered data import and modeling tool, and the Power BI service is better known for report building, collaboration, and sharing. The desktop provides greater access to traditional data sources like Oracle, MySQL, Teradata, DB2, but you can also use it for cloud environments. The Power BI service provides web content packs and also facilitates data connections to web environments, which we'll cover in an upcoming slide as well as in our demo. To fully leverage all of Power BI's features and functionality, you build, model, and create reports using Power BI Desktop, and you upload those PBIX files to the Power BI service. So when you publish, you're uploading a PBIX files into the Power BI service. The Power BI service also facilitates access to cloud-based data stores. It's important to note that the Power BI Desktop is free. As I said before, the Power BI Service Pro version starts around $10 per user per month, and there's also a Power BI Premium version for large-scale deployments. Microsoft provides an online pricing wizard for Power BI Premium. Power BI Desktop. In our slide, on the lower left side of the screen, we're showing the Power BI Desktop. That's the authoring tool. The desktop allows you to connect to on-premises and cloud-based targets and query, model, transform, and analyze that data. You can then visualize and publish, all using Power BI's desktop tools. We learned that the Power BI service also allows you to connect to web-based data stores, Excel files in OneDrive, SSAS provider websites, and other web targets. But you can also access data that's on premises. More on that later as we want to focus on the processing architecture. Data sets in our slide, they're really the heart of Power BI and can be created using Power BI Desktop, Excel, or on the Power BI site. Data sets include the tables, relationships, calculations, and hierarchies, and can be created from a variety of data sources such as SQL Server, Oracle, Excel files, flat files, websites. It's important to note that not only does it contain the constructs required by Power BI to process and display the report, it also contains the data used in that report. Data sets are compressed, but they have a 1 gig limit. Think of a data set as a container for everything mechanical you need to provide analytics, including the data to your users. In upcoming slides, we'll show you the different data sources you can connect to, as well as how to create the data sets. In his demo, Jeremy will also show you some very interesting Power BI features. There are times when it's more appropriate to connect the Power BI service directly to your on-premises data store. The on-premises data gateway allows you to create connections between your on-premises data sources and your Power BI service in the cloud. The gateway supports periodic data refreshes and direct query for certain data sources. If you use the gateway, it can pull data directly from the target data source, which means you don't have to worry about data refreshes and that 1 gig data set limitation. Microsoft offers both personal and enterprise gateways. The Microsoft docs explain the pros and cons of connecting live to your data via the on-premises data gateway versus publishing self-contained reports to the Power BI service. Some are pretty self-explanatory. If you need to access a lot of data, you may want to use the gateway. If you want fast data access to smaller subsets of data, publish the report, and you can schedule it to be refreshed. There are also some modeling and query limitations when you use direct query. Right above the data set in our stack is the Power BI report. A Power BI report is one or more pages of visualizations. It's really a collection of charts, graphs, and other visuals you build using the Power BI product. Reports can be created from scratch within Power BI or imported from other dashboards that are shared with you. Power BI will also automatically create them for you in some cases. A Power BI dashboard, the next step up in our graphic here, a dashboard is a panel that contains one or more tiles. Each tile displays a single visualization from a report. Since both reports and dashboards provide like functionality, we'll cover them a little more deeply in our next slide. Power BI mobile apps allow you to view the dashboards and reports from a mobile device. You can also view reports through the web browser, and you can navigate your published data models using Excel 2016. The iPad and iPhone apps for Microsoft Power BI for iOS offer live touch-enabled mobile access to your mobile reports and KPIs. Let's talk a little more about dashboards and reports. Dashboards contain visualizations called tiles. Tiles are visualizations pinned to the dashboard from a report. So on my slide here, each one of these graphics is a tile from a report. Dashboards are a feature of the Power BI service, and they're not available in the Power BI desktop. You create the dashboards and display them in the Power BI Cloud service. Dashboards allow you to combine data from multiple sources. We'll show you how this all ties in together in upcoming slides. With Excel 2016, you can publish your Excel workbooks right to your Power BI site, or you can create highly interactive reports and dashboards based on your workbook's data. If they're in OneDrive, you can access them in the Power BI service. You can also use the Power BI desktop to upload them. In addition, the Power BI service also allows you to access local Excel files. There's lots of different ways to work with Excel in Power BI. Here's some Power BI fun facts. It's just a one-page review of what we've covered so far. I think that what's important is that Power BI really isn't intended to be a total replacement for the more traditional on-premises SSIS, AS, and RS tech stack. Power BI in some use cases can be an alternative, but there are also many cases where it isn't. We learned that Power BI can use SSAS as a data source. You can access both tabular and cube data in SSAS from Power BI. Microsoft continues to enhance and improve SSRS, and some of those new features focus on strengthening a much tighter integration between SSRS and Power BI. You can think of SSIS, AS, and RS as the BI heavy lifters. You can extract, load, and transform large volumes of data using SSIS, analyze it using SSAS, and then display it using SSRS. Although you can extract data using Power BI, you won't be using that product to build large data analytics data stores. That's what you use SSIS for. Let's take a look at getting into the data into this Power BI service. After you get past the Power BI launch screen, you can select Get Data from the menu. You can see the different data sources that are accessible from the BI service. It's important to note that we are showing the Power BI service in this example, not Power BI desktop. You can connect to cloud services, the Azure SQL Data Warehouse, Azure SQL Database. If you install the on-premises gateway, you can connect to your on-premises databases, SQL Server, Oracle, DB2, MySQL, SAP HANA. There's a bunch of different data sources listed in the Microsoft documentation. You can also pull the PBX files you created in Power BI desktop up into the Power BI service. One of Power BI's most interesting features are content pack libraries. There are two different types of content packs. The Power BI service allows you to create your own internal content pack, which is stored in the My Organization section, and external services content packs, which are stored in the Services section. So what exactly is a content pack? This slide shows you a subset of the service content packs. Microsoft is working with all the major service providers that we use to run our businesses. We can connect to content packs for a number of services such as Salesforce, Microsoft Dynamics, Google Analytics. Power BI starts by using your credentials to connect to the service and then creates a data set, a Power BI dashboard, and a set of Power BI reports. They're all created for you automatically that show your data and provide visual insights about your business. After connecting to a content pack, you'll see a newly created dashboard, report, and data set. The content pack includes content from the service that focuses on a specific scenario, so they're not going to include all the information from that service. Once you perform the import, you can customize the displays to highlight the additional information. Here's a screenshot of a content pack for the GitHub service. The dashboard being displayed is stock with no modifications. When we connect to GitHub service content pack, this is our default dashboard. Microsoft works with the service providers to display the information that is most commonly pertinent to businesses that use that service. You can see that GitHub thinks that this information was what a broad range of their users feel would be most important to them. Here's the data source menu from Power BI desktop. You connect to the target data sources, transform, model, analyze, and visualize. Once you create a report, you have the capability of publishing it to the Power BI service. You can capture data and store it in the data set, or you can do direct query on some data sources. Reports created in the desktop, if you're using direct query, they can still be published to the Power BI service, but you're going to need the gateway, which allows the Power BI service to connect to the on-premises data stores. We learned previously that the Power BI desktop provides data modeling capabilities. When you compare it to the Power BI service in the cloud, it's really the heavy lifter of the two products. On the far right of this panel, we can see the table and fields we've previously selected. The tables are company project, project hours, and company employee. In the middle bottom of this screen, we see that we can create additional relationships between the data elements we've selected to build a report. The capabilities are much deeper than what I'm showing. We could spend a few hours on just the data modeling and data manipulation capabilities of the Power BI desktop product. The Power BI desktop tool also provides a very robust set of manipulation features. You can combine columns, create calculated columns, new calculated tables. You can split columns, perform date manipulations, pretty much anything you can think of. It's not the intent of this presentation to get into all the data manipulation features the desktop provides. The range of features are both broad in scope and deep in capability. The Power BI service counterpart does not provide these deep dive data manipulation and transformation capabilities. The desktop also provides strong data visualization features. If you look on the right side of the screenshot, you can see the visualization menu. Microsoft provides dozens of video tutorials on the powerbi.microsoft.com website that show you how to select data sources, model, transform, visualize, and publish. Once you've completed the visualizations, you can publish your report to the Power BI service. You can see on the slide we're publishing to Power BI. What we're actually doing is we're uploading the PBI data set the desktop tool is creating for us to the Power BI service. We learned that the data set is totally self-contained in that it's storing all the mechanics and the data we need for that report. You can also schedule refreshes for existing data sets that you've previously uploaded. When you create a Power BI report in Power BI Desktop, you can also create a version that is optimized for mobile phones. Then when you open a Power BI report on the phone, Power BI automatically detects that the report has been optimized for phones. If the phone optimized report exists, the Power BI phone app automatically opens up the mobile optimized version of that report. Let's talk about this Power BI service for just a couple of minutes. There's a couple of different ways to create reports in the Power BI service. We learned that we can create a report in the Power BI desktop and then we publish it to the Power BI service. You can also copy existing reports and modify them in the Power BI service, or you can import data directly into that Power BI service. It creates the data set for you, and then you can use the editing tools to create a report. We also learned that you can use pre-configured content packs which automatically perform a lot of work for you, like creating the data sets, reports, and default dashboard. I also wanted to show you workspaces, which is what Power BI uses to provide work collaboration. You create a workspace and begin the work creation process. You can use the workspace to share reports and dashboards with your coworkers. We learned that the Power BI desktop provides very robust data preparation capabilities. That's the product you would want to use to perform heavy data manipulations. The Power BI service does provide visualization capabilities, but heavy report development requires data modeling and lots of data modifications. The desktop is the most appropriate tool. We learned that you can create report dashboards in the Power BI service. You select a visual in a report and you can pin it to the dashboard. You have the option of pinning it to an existing dashboard or creating a new one. Once you pin the report to the dashboard, you can resize it, move it, change the title, traditional dashboard editing capabilities. You'll notice a prompt on the dashboard that says, ask a question about your data. It allows users to look at the data in different ways. When I first started reviewing the product, I liked the dashboard capabilities. I then learned that you can take a visual, hit the ask a question about your data button, and easily change the way the data is being analyzed and displayed. Maybe your visual shows a count of products sold by date. You can spin that view around to do a product sold by a manufacturer. You can then create a new component on your dashboard by pinning the new view of your data you just created. You can click on data element names, or you can actually type your request into the prompt. You can see a sample question at the bottom of this slide. What I'm asking is, show average selling area size by chain for these states. Microsoft provides a robust set of documentation on how to ask questions, the words and terminology it recognizes. Quick Insights is another interesting feature of the Power BI service. You begin by running the Quick Insights utility against a data set. Power BI then searches different subsets of that data set and applies a set of algorithms to discover potentially new insights on the data in that data set. The analytics include category outliers, change points in a time series, overall trends in a time series, seasonality in a time series, and correlations. Quick Insights isn't available in the Power BI desktop, and you can't run it against data stores that you're accessing using gateways and direct query. You can only run it against data sets you created in the Power BI service. I think we'll see Microsoft continue to enhance the functionality of SSIS, AS, and RS. We learned that although the tools do provide overlapping functionality, they're not really replacements for each other. Microsoft will continue to release features that more tightly integrate the product sets together. We already see Power BI's ability to interact with SSAS, and some of the features that are being released that tie Power BI and SSRS together. Each architecture provides a unique set of benefits that you can use to choose the best product for a given use case. Let's move on to the more exciting part of this presentation. I'd like to introduce Jeremy Frye, who's the product manager for RDX's Microsoft BI product offering. Jeremy is RDX's business intelligence subject matter expert and manages our Microsoft BI support team. So, Jeremy, I'm going to go ahead and make you the presenter for the presentation.
Thanks, Chris. And I know we have a lot of different attendees across the country here. So first off, I want to say good morning and thanks for joining, and good afternoon as well, and thanks for joining. So what we want to do in this portion of the webinar is to actually go through a small demo that just kind of showcases, some use cases of Power BI, and also some different stipulations of when you might want to incorporate additional traditional tools like SSIS, SSAS, and SSRS in addition to Power BI. So first, what I wanted to do is kind of step through and recap some of the screens and some of the interface of Power BI. As you can see, I have Power BI desktop open, and as Chris mentioned, this is a free download. You don't need a Power BI account in order to download and start playing with reports and building some different reports. However, I do recommend signing up for PowerBI.com so you can actually, publish reports if you need to use it, organization-wide. So if you can see here, it's very, intuitive how the interface is laid out. On my left-hand side, and I just want to go through this very briefly, is we have the reports area, which is here. So this is literally giving us some visualizations. Right now I've clicked on a horizontal bar chart, which just comes up as, a gray blank simulation of a chart at this point. When I actually add data and add a data set, you will see columns or fields here, which are drag and droppable into these different areas in your visualizations, which will then reflect in your graph. Also here, when we actually add some data, we will also see the outline of the data here, which would resemble like a table or an Excel spreadsheet. Below that, we also have what looks like 3 different tables, which defines how we can create a data model or define relationships between multiple tables or data sources here. And this is useful when you need to kind of expand on some reporting and what you're trying to do, and you have data in a couple of different places. You can literally build a data model here. At the top here, we can literally edit queries, we can enter data, we can select to get data from different places, and then obviously in our data model, we have information here. At our report level, we have some of the same functionality, and when you're not able to use certain functionality, it's grayed out here. So what I want to do now is I actually want to talk about the data that we're going to be showing in this demo. So everyone on the call may not be, a statistics fan. However, everyone on the call is a part of or runs some type of a business that incorporates some sort of data somehow that needs to be able to explain things in your organization, answer questions, or analyze data over a period of time, etc. So Power BI is useful for that regardless of what data you actually throw at it. What we're going to actually showcase today is NFL passing offensive stats. So our central office for RDX is located in Pittsburgh, Pennsylvania. So as you know, we're probably all Pittsburgh Steelers fans, and I apologize for those across different regions who are on the call. If you're not a Pittsburgh Steelers fan, however, you could tailor this kind of a report to your team of liking, so you can utilize it that way. So what we'll be doing is I'll actually show you the data. I just pulled together some passing stats for the entire offense across all 16 games for the 2016 season. So you can see here, it's a traditional spreadsheet. You might have spreadsheets laying around like this in your organization, or you might have end users or business analysts who have exported data out of databases, or who have massaged data in different ways and collected it different ways in order to perform whatever their day-to-day operations are in analyzing the data or reporting off of the data, etc. So you can see here I have some different fields that indicate stats such as interceptions, touchdowns, completion percentages, completion attempts, games, which game it was, or I'm sorry, this is a summary of games, so it's overall 16 games in a season, and then teams. So, obviously we look at this kind of data, and we might actually even send this type of a spreadsheet to people in our organization or to clients if we're a managed service provider, or if we're managing a piece of a business for individuals to supply them with reporting or data. However, your eyes can start to cross in different things when trying to compare these different pieces of data. So that's when we need to utilize a tool set like Power BI in order to analyze the data and give us great visualizations in order for us to facilitate and answer different questions in different pieces of our business to accelerate marketing campaigns, et cetera, in different areas. So that's just a use case example. So what I want to do next is I actually want to go into the report that I've created. So this is the report that I've created, which indicates Pittsburgh Steelers 2016 passing offense. What I have on the left-hand side is some KPIs, which are key performance indicators. What this allowed me to do was to focus solely on the Steelers' passing stats in 3 different key areas. One is total yards across the 2016 season, touchdowns, as well as completion percentage. So what I was able to do in my data set was I was able to establish what the averages were across all 32 teams, and then set that as a goal, and then maximize that based upon the target to show a color coordinated chart that indicates if I'm below, I'm equal to, or I'm above what that goal or that average is. So you can see here in all 3 phases of offensive stats, the Steelers ranked above the average, which indicates that offensively in 2016, they had a pretty decent season, maybe compared to other teams. What I can also see in this top chart here is all 32 teams. I've also established a green line that shows, hey, this is another goal of here's what the average is. Let's see which teams fell above or below that. So by literally just hovering over different access points here in my graph, this gives me the opportunity to be able to highlight a team and look at what their yardage was, or total yards, if they were above or below the average. So not only can I look at the Steelers and highlight the Steelers because that's the region I'm in, that's the team that I follow, but I can also compare that to other teams across the NFL. Now, if I wanted to do more of a side-by-side comparison, what I've been able to establish here is 3 additional graphs, or charts, I should say, that resemble what the Steelers' total yards, touchdowns, and completion percentage was. The unique things about these graphs is when I first open this up, the graph is blank. It doesn't showcase anything. Why I wanted to do that, and this is just one of the capabilities that would allow a tool like Power BI to accomplish for you, is that I only want to see, sometimes when you talk about, designing visualizations, one thing you can get into is building graphs and charts inefficiently that are hard to read or hard to establish what you're trying to get from that, or what kind of story you're trying to tell with that visualization. So because these charts are fairly small, if I were to try to plot all 32 teams in these smaller areas, it may become unreadable, or we may have a scroll bar down here which would require us to scroll. However, in order to encompass all teams on one graph, I have a more wider horizontal up here. Down here, I wanted to focus more specifically on selecting a team to compare against the Steelers to get a side-by-side comparison of the Steelers versus one specific team instead of all teams here at the top. So what I've designed here is I have a slicer that has all 32 teams. These graphs will not populate unless I actually choose a team. From that standpoint, it will show me the statistics across all three charts for that one team compared to the Steelers chart here, or numbers according to the Pittsburgh Steelers 2016 passing offensive stats. How I've been able to do that, and this is where some advanced design and development comes into place, is the query language that is utilized in Power BI is called DAX, and it's an expression language similar to expressions in Excel. What it allows you to do is to custom build new measures that you can facilitate in your graphs. So what I've been able to do, if you look here, here's a list of my fields that I have displayed. If you look here where I have highlighted, there is a team select. Beside it, it has an icon of a calculator, which indicates that it was a calculated measure that I actually created that was not in my spreadsheet. If I look at that, by just clicking on it, I get an expression editor at the top here, which will allow me to plug in some sort of an expression to facilitate what I want. What this is basically an if statement to calculate a count of teams that are selected within my group. So what that means is that if a team is selected here, then it will result to true. If not, it will result to false. How I was able to apply that to each one of these graphs is to actually click on a graph, which will allow me to edit that graph. Under filters, I was able to supply a filter to say, filter this graph and only display if a team selected is true or is equal to 1. So because I have not selected anything in my slicer on the right-hand side, you can see nothing shows up. Once I do that, then all three graphs will populate with the statistics compared to that specific team against the Pittsburgh Steelers. And so if we take, just by looking at this, what if I wanted to look at, I already know by hovering over this, the New Orleans Saints had almost 1,000 more offensive yards than the Pittsburgh Steelers. If I can look here and then also look here. But what if I wanted to, it can kind of be cumbersome sometimes depending on what kind of statistics information or how much is involved in your charts and graphs, to basically hover over this and then, make your eyes go back and forth between the two. It's easier to facilitate that across these graphs. So if I find the New Orleans Saints here and click, you can see that this now, because a team is selected, populated across every graph. This is a lot more visually appealing to compare also against the average for both teams across all three graphs. That way, if I want to select any other team, the New York Jets, for example, which were clearly clearly below the Steelers in a lot of different offensive areas, that gives me the opportunity to see that side by side. So that's how I facilitated this chart. What I would like to do next is actually show you, step through this portion of it and show you that this is a visual representation of the spreadsheet when you import it. When you go to the data modeling tab, this shows that if this is one result set or one table. If I wanted to create a data model here, what I would be able to do is import more data, which would indicate, if it was one spreadsheet, indicate another table here or another result set of some sort that I could actually create relationships between the two if I wanted to expand on the granularity of data that I have fulfilled in my chart or in my report as a whole. So that brings us to another situation that I wanted to talk about, and that's, proper data modeling. While Power BI does give you the proper information and the proper tools to be able to efficiently data model, sometimes what may happen is because this is a fairly easy tool to use, and obviously it can get pretty complex when you start manipulating the expressions to create different things. But what happens if I have 5 different business users or business analysts who can create reports, and they all generate things differently? They all generate different spreadsheets. They all facilitate and manipulate that data differently. What may happen is I may end up with 5 or 6 different spreadsheets, maybe 10 to 20 spreadsheets that have been used to compile reports, and they may not be properly data modeled. I call it data hoarding, because what ends up happening is, if they're all looking at if they're all looking at NFL stats, there's a possibility that there's overlapping data, whether that's teams, whether that's players, etc. Also, looking at this, the downfall is that I'm subject to what the granularity or data that is here. In order for me to bring in additional information, I can bring in additional spreadsheets that I mentioned and create different data models. But then what happens is I'm stuck with my data being cached in Power BI and the source data being in spreadsheets that have to be maintained at some sort of a file system. Now, an easy way to facilitate that from a data modeling perspective would be to maybe create some sort of a metadata layer that tells me and explains to me a FTP share or some sort of file share on a server, what the security is for that server, encrypt that, and what those spreadsheets are and a description of those. So anyone who needs to compile reports or they need to add to that can add to that repository, document that, and then you have sort of a metadata layer on top that can facilitate for your business users or end users who are creating reports, or even developers, where things are located and what exists in those, so we can coordinate that data appropriately. Another way to be able to do it is where we can incorporate traditional SQL Server tool sets. So if I pull SQL Server here, what I've been able to do is I've been able to build a extraction process to go out and gather NFL stats. And I've been able to create a third normal form relational model here where I actually have coaches, conference regions and conferences, executives for the teams, passing stats, players, player history. So if, obviously, we all grow older, we all have birthdays. So, players, the life term of a player is on average of 3 years, but across, a given season, a player can change age. So if you want to, start to look at statistics, for example, in this realm of a data set where we can compare, a decline maybe of a player based upon age and, deterioration of, physical attributes for that player, I can have history here that looks at over time when they've progressed in different ages. I can also combine receiving stats and rushing stats. So not only am I looking at just total offensive stats, I can break it down to receiving, rushing, as well as passing. And so what I have here is, as I mentioned, the limitation of this report is that I'm only looking at passing offense for 2016. What if I wanted to look at 2015? What if I wanted to drill down per player and look at passing stats per quarterback? So, in 2015, and I want to go to 2015 because I'm showing 2016, I actually built this data model and I can select from here and I can drill down, which would allow me to see the actual Steelers quarterback, which games they played in and what their stats were per game. So not just across all 16 games, what the total for the team was, but I can break it down even per game, per player. And what this data would allow me to establish is that I have a lower level of granularity. So I can see that in week 3, and this is within the 2015 season, that Ben Roethlisberger must have gotten hurt or went out of the game for some reason, that Michael Vick came in and actually, had some stats here. So, I can look at the 2016 passing stats, but if I wanted to look at player, I'm limited in this data set to only looking at it at a team basis. So this is when you might want to incorporate some traditional queries and database structures in order to facilitate more granular level of data. And so from that standpoint, what we end up with is exposing either views or queries to your business users or end users to allow them to build queries against one data set that's managed with SQL Server security, that's managed at a database level where you can do proper backups, et cetera, and be able to, facilitate the reporting needs and be able to expand and scale those reporting needs as well. So with that being said, the last thing that I wanted to show was, and Chris talked about it, very briefly, was the new services with Power BI, which the new model of Power BI Premium. What that allows is a completely on-prem solution. I know some of our clients have HL7 data or, are a part of different type of compliance regulations, whether it's HIPAA, OSHA, et cetera. So a lot of people sometimes may be leery of putting their data into the cloud. Well, with the on-premise solution, with Premium, Power BI Premium, you have the ability now to be able to do live queries and be able to store your data locally and cache it locally and store the report locally and not just in PowerBI.com. So in 2016, before Power BI Premium, you were able to upload a .pbix file, which is the file of a Power BI report here, to your SQL Server reporting services. However, when you click on it, it would just direct you to PowerBI.com to actually open that report. But now with Power BI Premium, you have the ability, if you sign up for that service and have that model, to be able to have a fully on-premise solution. Now, while this is currently in preview, it will be expanding on the functionality, once it's actually released. And, Power BI, one thing about Microsoft and Power BI is the community is heavily active. And so what happens is there's new releases almost pretty much every month, and new updates to PowerBI.com, et cetera. So you get a lot of different features that continue to come out. So Power BI is definitely catching up and even surpassing the field for other self-service reporting tools. What I wanted to show last before ending the demo portion of this presentation was to actually show you a reporting services that 2016 instance that I've installed locally here that comes with the SQL Server licensing. So you can see here that this is my 2016 report manager, which is the UI or interface for running reports internally in your organization that are SQL Server reporting services reports. So now with Power BI Premium, there's an actual Power BI report server. So when you download and install Power BI Report Server, you no longer need to configure Reporting Services Report Manager. You can actually deploy Power BI reports as well as paginated reports and SSRS reports to Power BI Report Server. So what I wanted to show you is I actually have two implementations, one of Power BI, the new report server, and then here's my SQL Server reporting services. So you can see that they're fairly the same, with fairly the same capabilities as it relates to the way the UI is designed. The difference here obviously is the heading or title is different because this indicates that this is the Power BI report server. At this time in the preview version, you cannot it only works for Power BI reports that are live query or direct query against an analysis services either in Azure or analysis services on-prem. Because my Power BI report was a cached report, so the data set was actually imported into Power BI, I cannot upload this currently in the preview functionality of Power BI report server. Just to kind of show you that. Now I'm assuming this will probably be changed in later releases of this, but if I select my dashboard here, which is the .pbx file that I described, and click open, it'll try to load it, but then it'll come back and say, it contains an unsupported data source connection or embedded data, which is what it is. This version of preview only supports analysis services and Azure analysis services. So I'm assuming though in the future, once this is released, you'll have further capability. So with that being said, that ends this demo portion of the webinar. I'll turn it back over to Chris and Kelly at this time.
Thank you, Jeremy. We did have a couple questions come in from the audience, so I'll begin with the first one. How robust is Power BI's Quick Insight utility that you run against the data set?
So the Quick Insight utility is a very innovative tool, and I think that it provides users who don't necessarily know exactly what story they want to tell or what they want to get from the data, so they can use that functionality in order to give them some sort of an insight into the data that's in the report. I think Microsoft has made significant improvements with it. I know based upon some people in the community and some different use cases that it hasn't exactly when it first was available. It didn't display or had some issues with the insight portion of it, but you know, I've used it a few times just to test the functionality out, and you know, I've found it to be intuitive, and I found it to be useful in some certain cases. My recommendation, though, is to go through your traditional business requirements and data discovery phases of, you know, talking to end users and talking to stakeholders and management and talking to individuals who need specific types of reporting to understand what it is they need and what their requirements are, and be able to facilitate that and you know, and design that yourself. So that's kind of my take on that aspect of it.
Thank you. And we had one more question. Does Power BI Desktop's data modeling capabilities reduce the amount of effort to model the back-end data stores?
That's a very good question as well, Kelly. And I would say it depends on the organization, and it depends on you know, the resources that are available from the IT side of the house. If you have very good developers and you have, you know, very good DBAs, I think it's still pretty beneficial to lock down your data at the SQL Server level and be able to control it on premises, or even in Azure if you use, you know, Azure database as a service. But I still like traditional database modeling. That way I can control it, and then you just expose the report developers or business users to certain views of that, or to row level security, et cetera, that you can utilize with like direct query, or that you can utilize for you know, for establishing a security layer. And you have control over that. You have control over the transformation. You're not relinquishing control just against users who, you know, if you have 15 users who have a Power BI Pro license who can actually get in and start developing, you know, yeah, Power BI does give you the capability to do some pretty decent modeling, but then you might end up with several different data models. And this is kind of recapping some of the things that I said earlier, is that, you know, although you can do some data modeling, your data modeling is per your report. And so when you create that report and you create that content pack, you know, others can use that content pack and you can share that. But then a lot of the times you get individuals, it's harder to manage is what I guess I'm trying to say, is that, you know, you can end up with several different data models that have overlapping data, whereas you create a traditional data model and then control the security to that, and then you can supply views and supply queries to those end users to be able to utilize. So it's kind of, it doesn't really minimize the effort of, you know, a traditional data model. It just provides some additional capabilities if you don't have a strong DBA or developer staff on the back end that create the proper data models, and you want to get quick reporting out, then, you know, it does give the capability to do that.
Great. Well, thank you very much, Jeremy. Those were all the questions we had from our audience. So I just want to thank everyone very much for attending today, and also Jeremy and Chris for hosting this presentation. We hope you can join us next month. Our presentation will focus on open source database management systems. We'll discuss where they fit and how they are positioning themselves in the market. So we hope you all can join us next month. And thanks again for attending today.
Thanks, everyone.